Is this working now? Open the calculator. All right, that looks like it works. Why wasn't it working before?
I like your apple shirt.
Thanks. All right, perfect. All right, my apologies. Let me get this back up on the board. There we go. That should work a little better. All right, so one thing about calculator questions on the AP test, and so therefore on my test as well. Calculator questions on the calculus testing arena are not like calculator questions on the SAT where it's like helpful to have a calculator. These questions are created so it is necessary to have a calculator. So if you're doing stuff by hand on the calculator section, you're doing it wrong. So make sure you're using your calculator when you need it. A lot of the time you'll be able to see with these questions, so like if you're working your problem set, if the questions are decimals, you're probably going to be using a calculator. Most of what we're going to be doing today is going to be focused on graphing, because graphing is a really great way to see when things equal certain values or when certain things equal each other, or to see intervals of time as we go through. So we're going to, for the first page, be really working with the calculator, how to graph, how to plug things in. The second page of these notes, these are technically calculator section questions, but you'll notice you don't really need a calculator for them. So these are going to be a little bit more theoretical in nature. All right. So calculator, here he is. We're going to graph stuff today. So I'm going to start by anyone know where you have to plug in your functions?
The graph.
Y equals. So in the top left corner, we're going to go to Y equals. And I want to just start by graphing the thing that was in our Y equals here, this top guy. We're going to talk about what we'll look for in a second, but I want to try to just type this guy into Y equals and try to graph it. Yeah. All right. Square root. That guy is blue above the x squared. If he's blue, you press the blue button first. So we're going to do second square root. X to the fourth for powers, you're pressing this little caret guy above the division sign. One kind of annoying thing is you have to get out of that exponent as you go. I didn't push down, you liar. Sorry, I have to like click around, which is super annoying. So you're probably already done. I'm going to do my +1. Make sure you get out of your square root before you start typing more. And you should have something that looks just like your paper. All right, I'm going to press graph. You should get a graph that looks like this. If you do not get a graph that looks like this, let me know and I can help. What's that? No, we're going to talk about why. All right. So, if yours doesn't look the same as mine, you may want to hit the zoom button at the top and hit zoom 6. That gets you in the standard window for the zoom. So if you got like a weird window going on. All right, let's talk about what we're actually looking for in this question. So the thing about these questions is we're usually going to have to do a little bit of translating before we start. That is not the document I wanted. This is. So we have F prime here, and then F is what we're being asked about. We want a local maximum on F. So kind of like when we were looking at graphs of F prime, we do want to kind of translate what this means, F has a local max, into what we would be looking for on F prime. Does anyone remember, maybe with a sign chart, how you would know if you had a local or relative maximum? Cool. If we had the sign chart, how would you tell if this thing was a maximum? Yeah, it changes from positive to negative. So I'm going to write myself a note. F has a local max when F prime changes from positive to negative. These are all multiple choice, so I'm going to be a little bit lax with my notation and my verbiage. So I am looking on this graph, since I have a graph of F prime, I am looking for where that graph changes from positive to negative. Does anyone see where that might happen? Give me an estimate of where you think. Where this graph changes from positive to negative? I think that's where it changes from positive slope to negative slope. So this is our distractor answer, because this is where this graph has a local maximum. We want where this graph changes from positive to negative. All right, I think what we're looking for is this guy right here. We want where this graph goes from being positive to being negative. So we want the x-intercept where we are changing from positive to negative. Now, we could do a couple of things to try to get what this answer is. I'm going to show you a couple. If you have multiple choices, you can kind of test those multiple choices using the trace button. So I could click trace and I can plug in any number I want. My guess is it's probably the 0.350 one. So I could plug in 0.350, press enter, and notice I get something that has like a negative exponent. That's effectively your calculator being bad at saying the number 0. I could also use the second calc menu. So if you press second trace, I could do this by finding a 0. That's option 2. Left bound and right bound just means a number to the left and a number to the right. So I can scroll. So I have my guy bounded between, and I could find it that way as well. So whatever you want to do, the important part is you need to be able to translate what it's asking for into what we're looking at on the graph. So there we go. We have this. The trace thing. So if you think you know what the answer is, so I think the answer is 0.350. When I'm on my graph, I can click just regular trace and plug in that value. Is that what you meant? Or the other thing? Okay. All right. Let's look at the second question. All right. We have between negative 1.5 and 1.5, we have this function. This is its first derivative. So again, we're getting a first derivative of this function. And I want to know all of the intervals on which f is concave down. All right, I want you to talk to your neighbor for a second. How do I know when f is concave down? I won't listen. I'm just going to sit here and wait for a second. All right, do we have any ideas?
When f prime is less than 0.
F, which prime is less than 0?
Just
For concave. Yep, so we could do f double prime is negative. Does anyone remember what we could look for on f prime? Cool, all right, we'll skip that then. If something's derivative is negative, what is it doing? Filling on its phone in the corner of my classroom. You could also look for where f prime is decreasing. What I'm going to look for is where f double prime is negative, because looking at a graph, it's a whole lot easier to see where something is negative or positive versus where something is going up or going down. That means, though, since I have f prime, I would like to graph the derivative of this. So I've got some instructions on the side here, but I'm going to show you how to plug this in. So let's go back to y equals. We'll clear out what we've got in there, and we're going to take a derivative of this function. Yes, your calculator can do that. So it won't tell you what the function is, but we can get it to graph the picture. So we're going to go to math. And I know I said number 8 on your notes, but look at what number 8 says. N deriv. Wow. So we're going to press number 8 in there. This notation looks a little bit funky. So we're going to put an x here to say we're taking the derivative with respect to x. And then we're going to fill in our function. The e to the x is on the left-hand side. It's, again, blue, right above the natural log. So on the line of the 4, 5, 6s. So we're going to do our second and our natural log button. You guys angry at me today or something? You're very quiet. Just tired. What's next? Oh, I thought you meant like here. I was like, what are we doing next class that you have? All right. I'm going to make sure that +2 is a big +2 down on the level with the e by making sure I -2. Thank you. Yeah, these functions tend to be really, really nasty because they want to make sure you're kind of using the calculator to do them. So it is always a good idea to check that you've plugged it in correctly. Now, the TI-83 calculators can't take the derivative and give you back a function. They actually evaluate at specific x values. So they could find you like f prime of 2. They can find you f prime of 3. There's another type of calculator that can actually say, I'm going to take the derivative of x squared and give you 2x as the output. But we can make this graph at any value of x by putting, it looks stupid, an x right here. So what this is going to do is as we graph, it's going to take the derivative of this function, and wherever it's graphing at that x value, it will graph the derivative at that specific point. You'll notice when we press graph, this is going to take a little bit longer to graph than it normally does because it's doing a lot of calculation as it goes. To help it out, I'm going to look at my question again. Do you guys notice that we have a very specific window that we're looking at here? So to help out my calculator, I'm going to change the window of my graph to match the window of those x values. So we're going to go to window, and I'm going to change some of the stuff in here. I'm going to change the x's to the ones that they gave in that explanation. And then since I know I'm going to be looking at where something's positive or negative, I'm just going to get a little closer to the x-axis. You don't have to do this, but I kind of like to shrink my window a little bit because otherwise the graph looks a little bit weird. So I'm going to go maybe -5 to 5. I can adjust that as needed, but really the x-min, x-max should match what's in your problem. So let's graph it. Let's see what he looks like. So this derivative isn't too complicated, but sometimes they take a really long time to graph. All right. So I remember reading about concave down, but what are we looking for on this graph? So we have graphed the derivative of f prime, which is f double prime, right? So if we're looking at this graph, what are we looking for on this graph? It's a lot less awkward when someone talks to me.
You're trying to find whatever it's concave down.
All right, we're looking for where f is concave down. We don't have the. All right, if we had graphed f prime, we would be looking for f prime is decreasing. We actually graphed the derivative of f prime, which is f double prime. So we're looking on this graph for where this graph is negative. Okay, so it looks like 0 to something. Again, we can find that multiple ways. If you want to just find it out of the blue, you can use the 0 function on your calculator and just make sure that you are going around that point. Why is there a square? All right, yeah, or you could trace in there 0 to 1 if you had an option of what you were doing. So I'm going from 0 to 1. Again, your calculator can be bad at approximating. So if you see numbers like 0.99999, that's just your calculator being bad at math. Is there anywhere else that this graph is negative?
Before the negative one.
Mm-hmm. Yeah, so we're looking at, I liked the 0 to 1 here. So we're going to go just on this interval. So notice they're starting at negative 1.5 and then going to negative 1. So we are looking for this. Nope, if they give you an interval as your start point, you're going to use that as your start point in the intervals.
Technically, we're saying we have similar questions where we have to write down the answer with negative infinity instead of the actual number. We just mark the point off.
I probably wouldn't if you are looking at a graph, but the problem is if I zoom this function out, I'm not super certain what it does after that interval because I was looking really close. So technically for this function, it looks like you're good to go, but if it had come back up at any point, that would create a problem. All right. Let's keep going. So one thing you'll notice is knowing these associations and being able to translate is going to be super duper helpful. So if you have to think really hard about like, oh, local max means f prime changes from positive to negative, or f is concave down means f double prime is negative, that's going to be really, really not helpful if you can't make those associations quickly. All right. Dos más actually. Second derivative. Now we're getting given a different function here. We've got the second derivative, and I want to know where does f have a point of inflection? Talk to your neighbors. How do I know when something has a point of inflection? All right, what should f double prime do if f has a point of inflection? Changes signs. Perfect. All right. Now, I don't think I mentioned it yet, but this question has trig in it. There are two ways to measure it with trig, radians and degrees. Anyone know the calculus version of that? Radians. So this is one of the biggest things I will remind you before the AP test. I apologize if anyone is taking physics as well, because you guys switch back and forth. If you press mode, that button that's currently red at the top of my screen, you want to make sure that this kind of fourth option here is on radians and not degrees. Otherwise, all of your answers are going to be wrong if there is trig in there. My calculators are usually always set to radians, but if you are a person that has a calculator that has to switch back and forth, just make sure you switch it there. All right, I'm going to go back to my y equals. We're going to clear this out. We already have the second derivative, so we're just going to plug this function in. Cosine is above those parentheses, kind of straight smack dab in the middle of your calculator. Oh, does anyone know how to make a big fancy fraction bar? Yeah, anyone want to learn how to make a big fancy fraction bar? We used to do this in Algebra 1 all the time. If you press alpha, y equals, and enter, you can get that big fancy fraction bar. Again, that is alpha, the green button, y equals, where we've been going to graph, and enter. Get that cool fraction bar. Otherwise, you're going to want to put your numerator in parentheses. You guys know all of this already, or am I just sort of? All right. I'm going to check this over as I'm writing it down. X squared cosine x squared plus 2x all over 6. All right. Cool. And I am going to press graph. I could change the window a little bit. Actually, let's do that. We've got a little bit of space to look at. We've got -4 to 3 is that interval that they've told us. Again, I'm going to change my y min, y max since I know I really only care about whether things are positive or negative. So get a little bit closer. What? Yeah, sometimes the functions, it just thinks a lot. You're actually allowed to have two calculators on the AP test if you want, because you can have like an 83 and an 89. So I was a nerd in my calculus class, and I had two calculators, and when one would lag, I would pick up the other one to do more problems. So the 89 can actually give you like if you take a derivative, it can give you the function back. So if you take the derivative of x squared, it can tell you 2x, whereas this calculator just is like, hey, plug in an x value and tell it to me. But the 89, its technology hasn't been updated since like the 80s. So all of this pretty print that you have, where it's like math 8, and I get all of this notation. The 89, it says like n deriv parentheses, and you have to do a lot more input stuff. So you have to do like your function, comma, x, comma, the number you're plugging in, or it's a lot. All right. Anyone think they know where we're looking here? Yeah. All right. Yeah, a little after too. Does 0 count in this case? Why not? Good. We have a possible point of inflection there because we have it equaling 0 on f double prime, but there is no sign change. So I'm guessing it's that 2.229 number. So I'm just going to press trace and try to plug that in, not with 2 decimal places. All right, I'm getting a number that's very, very close to 0. That's probably a rounding error as far as the calculator goes. So I'm going to choose that one and only that one. Notice that they did have 0 in an answer choice. You just want to be really careful about which one you're choosing. All right. Let's see if anyone was paying attention last class. What did we learn last class? The second derivative test. All right. So, like I said last time, there are very few questions where I can force you to do the second derivative test. We did one last time where I gave you a differential equation, so we couldn't make a sign chart because we didn't know how can I plug in a number left and right of both x and y. This is another way to force you into using the second derivative test because I'm giving you very, very specific pieces of information. In that, I'm giving you 2 critical points on f. So I know that these are possible relative maxes and mins. We have these 2 critical points. But I'm only giving you a second derivative here. So I need to plug these into the second derivative to find out whether they are maxes or mins. So we're going to try to evaluate f double prime of 0 and f double prime of 6.949. And once we do this, the hard part of today is over. All right, I find plugging in annoying, so I would like to only write this function once. So I'm actually going to go back to the graph to do this. I'm going to plug this into y equals, and then I'm going to use that trace to plug in to find out what's going on. So let's plug in our function. We're still in radians mode because we didn't change it. -2 cosine. Oops. Make sure you close out your parentheses. All right. And I am going to zoom 6 this guy to get him back to the normal window. A very fun graph. I do kind of enjoy that it like traces it instead of Desmos, it just pops up. What's wrong? Oh, yeah. No undo button either. All right. If I plug in 0 here, I get the y value, which in this case is our f double prime. That's what we plugged into our y, of -2. Why do I care? What does that tell me? Reminder, what does f double prime tell me about? Big word starts with C. All right, concavity, that number is less than 0. So what type of concavity do I have? This is concave down. So yes, this will be a local max. All right, if we do the same thing, point for 6.949. We get negative 1.817, always 3 decimal places, but it doesn't really matter in this case, because what I care about is that it's less than 0. We're still concave down, so we have another local max. So what is my answer? D. So thrilling. All right, could we already use a break?
Yeah, sure.
All right, when we come back, we're actually not going to be using the calculator, but we are going to be doing calculator section questions. So a lot of the questions in the calculator section aren't going to use the calculator at all. They're going to be a little bit more theoretical in nature. They might give you a graph, give you a table, something like that. Let's go ahead, take a break. You guys sound tired and quiet, so maybe give your neighbor a high five. Wake yourself up. You have 4 minutes. Yeah. Still no one answers. Cool, cool. Y'all make me feel really popular thing. Jay's saying 5 to 8 inches. That's exciting. Yeah.
Went from 40 to 16.
I don't think 40 was ever real. I think Mr. Camp was lying to you. So quiet as calculus class over here. All right. Let's keep the fun going because I know you guys are having a good time. So, we're going to look at some kind of more theoretical questions on the back of the front page. These will probably be questions that are going to be like the ones if you're on the AP test that you will see on the calculator section, but you're going to notice that there's not really anything I can do with the calculator. A lot of these words, still the same idea of translating into the information that we're being given. A lot of the time we're going to be talking about either the graph or a table of f prime. So let's look at this first guy. We have got values in a table of f prime of x. We are being asked about f of x. So that's going to have us translating the information into something about f prime. We also can kind of get a little bit of an approximation of f double prime going on if we find that information important. We'll talk about that in a second. How do we usually tell if the graph of f is concave up? What comes to mind? F is concave up. Does anything come to mind when I say the words concave up? All right, f double prime a lot of the time comes to mind. You start thinking about second derivative test. What does f double prime have to be for f to be concave up? Yeah, less than 0. So when we're looking at this, if you want to get kind of an approximation for f double prime going, what is f double prime in relation to f prime? The derivative. And what does a derivative normally mean, like on a graph? Slope. It's like a rate of change. So one thing I can do is I can look at the rates of change between these y values to kind of get an approximation of what f double prime is doing. We could find an all-out slope, but I'm just going to look at the change in the y values because we're really talking about positives and negatives here. To go from 3 to 1, that's -2. To go from 1 to 4, I'm adding 3. 4 to 7, adding 3. 7 to 5, I'm subtracting 2. So I don't really care that the slopes are different, and I'm not really looking at changes in x, but I can see that my f double prime isn't always less than 0. I've got some places where the rate of change of f prime is positive. I've got some places where the rate of change of f prime is negative. So this one is not going to be true. All right, the second one says the graph of f has at least 2 points of inflection. When I say the words point of inflection, what comes to mind? What changes sign? F double prime changes sign. All right, does it look like F double prime is going to change sign at least 2 times? I would say yes. I have a -2 to a +3 to another +3 to a -2. So that's going to have to happen once at least in here and once at least in here. So I'm really liking letter B. I'm going to circle it, but let's just roll through the rest of them to talk about some kind of weird stuff about tables. All right, F is increasing. What does that make you think of? Something's positive. What's positive? Which prime? F regular F prime. Now, does it look like F prime is always positive? It looks like it in the table, right? We got 3, 1, 4, 7, 5. Here's the kind of bad thing about tables, though. Do I know what's happening at x equals -1? No, I have no idea. Anything could be happening inside the intervals of space where I don't have x values. So while that could be true, we are operating under the must be true category. So I could have any slopes between those. I could go from 3 to like -1,000 right here. I have no idea. So that doesn't have to be true all of the time. All right. F has no critical points. What does the word critical point make you think of? Yeah, F prime equals 0. Kind of the same argument. We don't know what's happening in between these points, so we don't know if there are critical points or if there are not. Those might be true, might not be. F has at least 2 relative extrema. That would be a relative max or min. So we'd have to have some critical points happening. Then we'd have to have either some sign changes in f prime or maybe doing some second derivative tests there. Since we don't know how many critical points there are, I can't think that we could say anything about two relative extrema. So B is going to be our answer. So again, being able to translate that information into what you're looking at on the table or on the graph, very, very important. All right. Let's translate. What is this the graph of? Whenever we're given a graph, we need to know what it's of. Who is this graph? F. All right. So we have the original function graphed right here. We know f prime is positive and f prime is increasing. What does f prime being positive mean? Positive slope. So I would say that f should be increasing. All right. If f prime is increasing, what does that mean about f? All right, so that means the slope itself is increasing. What? Well, one way I could translate it is I could say, well, if something's increasing, its derivative is positive. So f double prime is positive. What is f double prime being positive? Tell me. What? Does f double prime tell me about in general? Big word, starts with C. Concavity. If we're positive, what type of concavity do we have? Let's go up. All right. So we are looking for a point on this graph where f is increasing and f is concave up. Talk to your neighbor. Decide, where is this graph increasing and concave up like a cup? All right, can it be A? No, this graph is decreasing there. All right, can it be C? Why not? Oh, okay. All right, it's concave down here. I skipped B. B's looking a little wonky, right? We don't have any f prime or f double prime. This guy's not differentiable here because we have a sharp turn. Which one did you think it was? E. All right. D is decreasing, so I don't like that. E here, we are increasing and we're concave up like a cup. So E. All right. Really? Are we having fun? No? Liars. All right. The graph of f prime is given. So here we have f prime over here. We have to make sure we know what we're looking at on a graph. We need to be able to translate these things. I'm just going to do this one real fast because it's really repetitive at this point. So we want to know which of these 1, 2, 3 things are true. Everyone love 1, 2, 3 questions. They're so fun. All right. So we have f has a relative minimum and x equals -3. That's right here. You might be tempted to say that doesn't look like a relative minimum at all. But wait, this is the graph of f prime. So a relative minimum, thinking about like a sign chart, we would want f prime to change from what, negative to positive? Is that happening at that purple point right there? Yeah. We're going from negative up to positive, from negative y values to positive y values. So that would be true there. A point of inflection on f prime. So if we have our point of inflection on f prime, we should be looking for kind of a change in the sign of our slope. Well, wait, what am I saying? Yeah, the change in the sign of our slope on f prime. You could change from increasing to decreasing so that the sign of f double prime would be changing. So you could have f prime has a relative max or min. Lots of ways to say that one. If we look at x equals -2, that's about right in there. Nothing is happening there that's good. It looks like the concavity of f prime is changing, but we want the concavity of f to change. So this guy is no good. All right, for f to be concave down from 0 to 4, usually I think of f double prime being negative for that. But if I think about f prime, I would want f prime to be decreasing because that would make its slope f double prime negative. Looking at from 0 to 4, that's all of this stuff, that is decreasing on this graph. So I am good to go, and I want 1 and 3. All right, last one, and then we'll draw pretty pictures. What graph is this? F double prime. So we can get any of the 3 graphs here. We want to know, where is F concave down? What am I looking for on this graph? We're looking for where this graph is negative. Where is this graph negative? All right, -2 to -1, and 1 to 3. Huzzah. Wind chimes. All right, let's draw some pictures. So the last thing we're going to do today is called curve sketching before we do a little bit of a notes check. Curve sketching is essentially what we've been doing, but kind of in reverse. So I'm going to give you a bunch of information, and we're going to draw a picture of a function that we're kind of noticing. So we're going to take all of this derivative information, and we're going to say what it means about the graph of y or about the graph of f of x, and then we're going to actually draw that picture. So I'm going to look at first the points in this table. So looking at this table, does anyone see any points? All right, those are x values. What are the y values? Okay, so 2, 1, 4, 4, and 6, 7. I am going to draw those points first. You want to stick those points on your graph absolutely first, because it is so difficult to change them once you try to draw other stuff. So I've essentially got different chunks of this graph. The chunk that's less than 2, the chunk that's between 2 and 4, the chunk that's between 4 and 6, and then the chunk after 6. I'm going to try to translate all of this information into information about y so that I can draw each of those things specifically. So, for example, this first set of information here, when y prime is less than 0 and y double prime is greater than 0. Can anyone translate for me, what does y prime less than 0 mean about the graph of y? If something's derivative, first derivative is negative, what does that mean about the graph? We're decreasing. Okay, first derivative being negative, we're decreasing. All right, the second derivative being positive, what does that tell me? Second derivative normally tells me about concavity. If we're positive, we're concave up. Okay, so I need to draw something that is concave up but is decreasing, and I need to run into this point at the end. Kind of looking forward at the point 2, 1, I noticed that at 2, 1, y prime equals 0. Y prime is like our slope. What does something with a slope of 0 look like? Could you do it with your arm? What does that look like? Yeah, Sadie's got it. It's flat. So as I'm coming into this this point right here, I want to be flat. I'm going to try to take up most of the graph, but it's a little wishy-washy. My graph is probably not going to look exactly like Matt's graph. It's probably not going to look like exactly like Derek's graph, and that's okay. Yeah, what's up? Yeah. So I'm gonna come in like this. So I'm trying to take up a lot of the graph, but if I drew something like this, I wouldn't be wrong. So they can be a little bit different. All right, let's move on from 2 to 4. We got y prime is greater than 0 and y double prime is greater than 0. What are 2 things you know about the graph of y? Decreasing or increasing? From 2 to 4. Increasing. All right, concave down, concave up. I heard both, so which one is it? Greater than 0, so we're concave up. All right, peeking forward, I notice that at 4, my slope is still supposed to be positive. Ooh, y prime double prime equals 0. That's interesting. So I'm going to try to draw something. This one's already always hard for me to draw, so I'm going to round 2, maybe round 5 it. Don't be scared to redraw your segment if you don't like it. Mine looks lumpy still. That's better. All right. Looking from 4 to 6. Y prime is greater than 0. Y double prime is less than 0. What's happening? All right, we're increasing, and you're right that y double prime did change sign. So, what concavity I'm gonna have now? Down. Anyone notice that change in concavity? What's happening at x equals 4? If we change concavity, what's the name for that? A point of inflection. So we can see if that looks like that. Peeking forward at x equals 6, it looks like we're going to be flat again. So I'm going to try to level out as I go. Something like that. We can see that change in concavity. We went from concave up to concave down. What? It's flat up here. What? It's like it's curving in there. You'll see it in a second. All right, and then after 6, we've got y prime is less than 0, so we're decreasing. Y double prime is less than 0, we're concave down. So I'm going to go and I'm going to continue this way. So there's my flat guy right there at the very top. If you drew a tangent line to him, it'd be a tabletop like that. All right. And that's curve sketching. That's really it. You guys want to try curve sketching on your own? Or do you want to do one more together?
Yeah.
All right, can you pick me a color to do my curve in? I heard blue first. Which blue would you like? This one? The light blue. All right, we're going to go a little... All right. This one's old. 1991. This question is almost as old as I am. How fun. This one's a little weird because of the presence of the word even. We'll talk about that in a second. But we're going to translate some first. Also, we see some interesting stuff with these undefined here. We're going to see what that looks like. I am still going to plot the points first. So I'm going to plot 0, 1. That's here. I'm going to plot the point 1, 0. That's here. The point 2, -1. Now, I do notice that they're telling me to graph a function from -3 to 3. So that's a little bit interesting that they've given me those points right there. And they haven't really talked about any negative x values at all. All right, I'm going to look at from 0 to 1 first. They're telling me f of x is positive. That's interesting. That mostly just means I need to be above the x-axis, which makes sense. I'm trying to draw right there. I have a first derivative that's negative, so I should be drawing something that's decreasing. A second derivative that's positive, so I should be drawing something that's concave up. So looking forward at 1, 0, the derivatives are both 0 there. So I'm going to be trying to flatten out as I roll in. Maybe something like that. All right, in the middle here, I got some flatness because of my first derivative being 0. What should be happening from 1 to 2? What should that look like? We've got negative, negative for my first and second derivative. Decreasing and down. So I still want to be having my graph travel downward, but it should be curved like a frown. I hate that. I'm going to try again. All right, I like that better. All right, we've got these undefined things happening. I'm going to see what's happening from 2 to 3 and see if it becomes obvious what's happening here. What's happening from 2 to 3? I've got a positive first derivative and a negative second derivative. Increasing. All right. Ooh, that's kind of weird. Yeah, it's going to be a V type of thing. Now, I'm choosing to make mine really symmetric here, or like, I guess just aesthetically pleasing. But I could be aggressive and like go all the way up here. Well, no, I couldn't because I have to be negative. I could do like this if I wanted to, but I want to make it nice. There's a lot happening in the hallway right now. All right, now I have a problem. Oh. Okay. All right, so these undefined things, that's coming from the sharp turn that you're seeing. So yeah, the V kind of shape that's giving us an undefined first and second derivative. We're not differentiable at those places. I'm confused though, because I'm supposed to draw from -3 all the way up to 3. How am I going to do that? Yeah, so these undefined usually will tell you that you're a sharp turn. I technically could also draw something that's discontinuous, but this told us our graph had to be continuous, so that's the only choice. You could also do like a vertical tangent line. That's a little weird here.
Like, isn't that undefined too?
Yeah, so we kind of need to draw the other side of this graph, and that's going to come when we draw the other side of this graph. Does anyone see a word that might help us draw another side to this graph? Or is there a word that's there? Seems to be important, and we haven't used it yet. Even. Now, this is maybe a callback to like maybe pre-cal. But think of like even powered things. So like x squared, x to the 4th. Cosine is an even graph, if you remember what that looks like. Does anyone remember something about even graphs and maybe some? Yeah, they're symmetric, and they're symmetric about the y-axis. So what we're going to do is we're going to take our graph and we're going to pretend like this is a mirror, and we're going to reflect it over there. What you'll notice, Sadie was saying that this should be undefined at, my derivative should be undefined at x equals 0. That's going to happen when I reflect this over. So that was a good notice there. Now, they don't usually do things like this now. Use the idea of evenness to have you draw the other side of the graph. That's why this is such an old AP test question. I thought it was kind of cool. So we're going to have this cute little graph. All right. And the last one, you get to do on your own. This is my favorite one, the last one. Everyone tells me it looks like something specific. Let's see if you agree. 2005, were you guys alive in 2005? Oh my God. Cool. All right, try this one. I'm going to get your notes checked right now. Make you guys stand up and move around. I was in this building. Yeah. Yes, I was 2005, a freshman. Sophomore. So I was not yet doing calculus.
What classrooms do you have classes in here?
Oh yeah. Because this got built. Well, this got built around 2005. This wing of the school. Yeah, we used to not have the bridge. So if you wanted to go from English to science, you had to go downstairs through the main hallway and go back upstairs. Oh yeah, Miss K was my BP teacher, and then she hired me. What a crazy idea. Miss Thomas was my English teacher. Pretty much the whole science department got me. Because I had Miss Leonard her first year here, Miss Moulds her first year here. Mr. Benedict was my first science teacher.
They like all remember when we came back.
Miss Moulds did not, which is funny. Your first year teaching though is very stressful. Don't blame her. Yeah. I really want to hire one of my former students now because I hired me, so then it'll be like her brand teacher name. But everyone wants to be a teacher. I'm back in the hiring. Not that I have any ability to do hirings and firings right now. Nice. And so I've already sent one person off to like not to do.
I think she has a letter.
Does it look like anything?
It's beautiful.
Yeah. What does it look like?
Yeah.
That's what everyone always says. All right. What kind of roller coasters are you going on? That sharp turn at the top would be a little frightening.
He was with the exit note, like, I was talking about, like, so much about that. And, like,
Oh yeah. So that notice that you have like that sharp turn at the top.
oh, yeah.
So they're trying to kind of get you to realize that the derivative is not going to exist there. It's a little bit hard to write that in a table. So I think whoever wrote this question was real nervous that you wouldn't understand what they were trying to write in the table. Yeah, it is good to notice though when they make big deals about things. All right, so what am I doing? Increasing down. Flat, increasing up. Decreasing. All right. Should look something like that. Yes. All right, we feel good about today. All right, you have, ma'am. Yes. All right, your notes check today is on the blue pieces of paper I just hung up around the room. There are 5 questions. You do not have to do them in order, but most of them are calculator questions, so we can practice that. You have a chart with 6 boxes on it. The first one says my name is. That one should be relatively easy to answer. The other 5, I would like the letter answer, also just a little bit of explanation. Does not have to be good, but let's say you're looking for, like, it asks for where, I don't know, F is increasing and you've got F prime, you could write like F prime is positive. If I see you just copying someone else's paper, I'm going to chuck yours in the trash. So make sure you know what you're doing. You have a significant amount of time to do this since no one wanted to talk to me today. So if you get done early, feel free. I think there's like 4 calculator questions also in your problem set. Make it your goal to get all of it done today. I did do the Google Meet. Why? don't know if anyone logged in. Maybe I'll check. All right, it's the blue pieces of paper around the room. One is up here, and then I went numerically around. You may have to stand up. The blue ones. You can start wherever. There's no. Nope, no one joined us today. If you want to ruin it like my old students used to, you can just take pictures of all of them and then sit back down.
It's actually a very good.
I shouldn't have given you the idea.
Yeah, that was actually really good at actually.
I was saying I made the font really big, so you could probably get it done. No. All right. Well, at least you'll have to walk around for like 2 seconds to get some pictures. I give up with you all today. I was so full of energy walking into class. You're just bringing me down.
Today is a Thursday.
Yeah. Why is everyone so tired and sad today?
It's a Thursday. It's a B day. It's a Thursday.
Stop complaining about my class when I'm right here.
This is not about your class. It's about the rest of the day.
Thanks, Matt. This isn't the first week back from winter break.
It basically is. I haven't been in this class for 11 months.
We might have a snow day next week. That would be exciting.
I mean,
Wow. You guys are just so optimistic and uplifting. I love every moment of being in this class with you all when you are like this. The 40 inches of snow.
mariachi band last night.
A mariachi band? That sounds like a fun story. I guess I can stop the recording now. They don't need to hear about.
a total of 5 hours of sleep.
I don't know. Stop recording.